What's up, everybody? In this video, we're going to take some notes on solving multi-step linear equations. Make sure your name's on this and make sure you've shared it with me. The TEKS standard that we're trying to master is standard A5A, which says to solve linear equations with one variable, including those for which the application of the distributive property is necessary. So we know we're going to be using distributive property, and for which variables are included on both sides. So if you're confused on what exactly this TEK is saying, we're going to learn to solve these two types of problems. We have first a linear equation that has variables on both sides. So in this left example, you can see that there's an x variable on the left side of the equal sign. There's also a x variable on the right side of the equal sign, that is. And then the second problem type is solving a linear equation that has distribution in it. So if you look here, this -5 is outside a pair of parentheses, and so we know we can distribute that -5 and then solve. So the question we're asking ourselves really is, how do I use algebraic operations to solve for a variable? So we learned about operations last week. We know that we have operations, and each operation has an inverse. So we can do an operation and we can undo operations. Let's look at some main ideas. We need to know that solving for a variable means to isolate the variable on one side of the equation in order to know the value of the variable. Essentially, that means we're going to get the variable by itself on one side of the equal sign and have it equal to some number. We also know that an operation must be done to both sides of an equation in order for it to remain equal. And we learned last week that algebraic operations can be undone using the inverse operation. So let's look at the first type of problem, which is a linear equation with variables on both sides. The first step that we need to do when we have a variable on both sides is to use addition or subtraction to remove the variables from one side. Step 2 is to identify the order of operations of the equation and list them in the correct order. So this is what we did last week. Step 3 says identify the inverse operation of each item from step 2. So we're going to take all the operations from step 2 and list their inverse. And then step 4 says we're going to carry out the inverse operations in backwards order. So step 4 is the key, because we're undoing all of the operations that have been done to the variable. So let's do two examples of this together, and then you can try one on your own. This first example says we're going to solve for x, and the equation is 5x plus 8 equals 2x minus 19. So first we're going to use addition or subtraction to remove the variables from one side. So what do I mean by that? Well, let's type our equation here. 5x plus 8 equals 2x minus 19. So I've got x's on both sides of the equation. What I want to do is I'm going to subtract 2 x's on both sides of this equation. Because when I subtract 2 x's from the right side, I'm going to cancel those x's out. And so what I'm left with, when I simplify, I do 5 x's minus 2 x's. So I've got 3 x's plus 8 equal to negative 19, because once I subtract these two x's from each other, they become 0. Okay, so we've done step 1. Now we have variable x on one side and one side only. So let's identify what's happening to that x. First we have multiply by 3, because in order of operations, multiplication comes first before addition. So the second operation we see is add 8. In step 3, we're going to take this list in step 2 and make it into inverses. So the inverse of multiply by 3 is to divide by 3. And the inverse of add 8 is subtract 8. We're going to take this equation, I'm going to copy and paste my simplified equation to step 4. Now we're going to do these operations in step 3, but we're going to do them backwards. So I'm going to start with subtracting 8. So if I subtract 8 from both sides, minus 8. I know that 8 minus 8 is 0, so on the left side I just have 3x is equal to, and then on the right side I need to do negative 19 minus 8. Negative 19 minus 8 gives me negative 27. The next step is to divide by 3. So I'm going to divide both sides by 3. I'm using a backslash to represent division. 3 divided by 3 is 1, and 1 times x is x. I have x is equal to negative 27 divided by 3. That gives me negative 9. So now I know that x has a value of negative 9. Let's take a look at example 2. Example 2 says we're solving for x. We've got 5x plus 8 equals negative 4x plus 9. So let me write that here. Negative 5x plus 8 is equal to negative 4x plus 9. Now in this situation, I've got negative coefficients on both of my variables. So instead of subtracting x's, I'm actually going to add some x's. So I'm going to add 4 x's to both sides of this equation. And because I've added 4 to both sides, when I simplify, I get negative 5x plus 4x gives me a negative 1x plus 8, and this is equal to negative 4x plus 4x is 0. So I just have 9. So now I want to identify the order of operations happening in this equation right here. The first thing that I see is a multiply by negative 1. So this negative sign here is multiplying by the variable. And then after multiplication, I see addition by 8. So when we identify these inverses, the inverse of multiply by 1 is divide by 1. The inverse of add by 8 is subtract 8. So let's take this simplified equation here. We're going to copy and paste it into step 4. And we're going to carry out these inverse operations in reverse order. First, we're going to subtract 8 from both sides. Minus 8 here and a minus 8 here. 8 minus 8 is 0, so on the left-hand side of the equation, all I have is negative x. 9 minus 8 is 1, so on the right side I have 1. Now I need to divide by negative 1, since I have a coefficient of negative 1 on my x variable. So this is really a negative 1, x divided by negative 1, so that just becomes x, because negative 1 divided by 1 is 1. But 1 positive 1 divided by negative 1, that's going to be a negative 1. That's going to stay negative. So x itself is equal to a negative 1. Try example 3 on your own. If you have questions or if you get stuck, you can ask me for help. And if you want me to check your answer, you can ask me for help to do that as well. We're going to end this video here. And in the next video, you're going to learn how to solve an equation that has distribution in it. So after you complete example 3, you'll find the next video. I'll be putting an extra slide in here to do these next couple examples about distribution.